Welcome. So in this lesson, we're going to be talking about application of straight line graphs, and this is exercise 9H. Well, let's begin by linking distance with time with this example right here. A hiker walks a constant rate of 4 kilometers per hour for 4 hours. Okay, so we have a hiker who's walking at a constant rate of 4 kilometers per hour for 4 hours. The first thing that we're being asked to do here is to draw a table of values using t for time in hours and d for distance in kilometers. Use t between 0 and 4. So let's create our table of values here. We have t, which stands for time, and distance, which stands for the distance traveled. Now we're being told to use t between 0 and 4. So that's 0, 1, 2, 3, 4. And we now need to figure out what the corresponding distances are going to be for each of these t values. And that's where we really have to read the question carefully. We're told that this hiker is walking at a constant rate of 4 kilometers per hour. So after each hour, this person has walked 4 kilometers. So after 0 hours, so in other words, they haven't started at all, it's quite clear that they've gone no distance at all. After they've walked for 1 hour, it's quite clear that they've walked 4 kilometers because they're walking 4 kilometers per hour. After 2 hours, it's quite clear that they've walked 8 kilometers. And we can think about this in terms of, well, they're walking 4 kilometers an hour. We times that by the amount of hours they're walking. So 4 times 2 is 8. And then we just keep on going here. After 3 hours, well, they've walked 12 kilometers because 4 plus 4 plus 4 is 12. And then last but not least, after 4 hours, it's quite clear that they've walked 16 kilometers. And to do this mathematically, what we're doing is we're just timesing 4 by the amount of hours we're walking. So this is what we're doing. That's how we're generating this table of values. Perfect. Now we move on to part B, in which we draw a graph by plotting the points given the table in part A. So now what we want to do is we want to take this information here and plot it on our table of values. Sorry, we want to take the table of values and plot it onto our graph. Now, the reason why this is a bit different to what we've done previously is because previously we've only talked about y and x. But we don't have y and x in this case, we have t and d. So that means instead of x, I put t here. Now, the reason why I know to put t here is because time always goes on my x-axis. Because time is an independent variable, it always goes on my x-axis. And when I say independent variable, it means that nothing affects time. It's the constant. Well, constant has another meaning there, but it is the thing that isn't affected by anything else. Nothing affects time. Time just keeps on going. My distance, on the other hand, goes onto my y-axis because the distance is affected by the time. So it's the thing that is changing in relation to the time. The next thing that we have to do when we're in these situations, and we've got like a real-world application, is we have to think about how we're going to scale out our axes here. So for my time, it's pretty easy. I can just go 1, 2, 3, 4. For my distance, do you see how I only have 1, 2, 3, 4? Only 4 lines to deal with here. But I have to go up to 16. So we're going to have to be smart about how we scale this thing up. What we're going to do is we're going to go up by 4. 4, 8, 12, 16. Now this is very much dependent on how you draw the graph. If you wanted to, you could draw this so it goes up by 1, but you'd need a lot more room. But you can scale it any way you choose. You just got to be careful with how you do it. All right, now that we've done that, we've scaled our graph. The next thing that we do is we plot our points. So when t is equal to 0, d is equal to 1. So we'd come over here now and we'd say, well, this is going to be here, 0, 0. When t is equal to 1, my distance is equal to 4. So this point here, 1, 4, is just this coordinate, 1, 4 there. And then we keep on going. 2, 8 would be here, 3, 12 would be here, and then 4, 16 would be there. And now I can draw a line connecting all of these. And that is how we do it. That is how we create a graph based on the table of values that we were given. Perfect. Now that we've done that and we've created our table of values, the next thing that we've been asked to do is to write a rule using d and t. Whenever they ask you to find a rule, the first thing I want you to do is write down your general form of a linear rule, y equals mx plus c. Now we know that we're not dealing with y and x, we're dealing with d and t, so you're going to have to replace them. Now remember, d is on your y-axis, so that means my y here is d, and my x, that's t. So I'm going to get d is equal to mt plus c. The next thing you're going to do is you're going to remember what your m and c values actually mean. So what is your c actually telling us? Well, we know that the c is telling me the y-intercept. Now, in this case, you wouldn't call it the y-intercept, would you? You'd call it the d-intercept, but the idea is the same. And my m is what? My m is telling me the gradient. So in the back of your mind, you need to know what the c and m value mean. Because now we can come to our graph and we can say, well, what is my c value? Well, the point at which I have a d-intercept, it's a bit confusing to say d-intercept, the y-intercept in this case is just 0, isn't it? So that means my c is going to be equal to 0. And what is my, sorry, not d, what is my m value going to be? So in other words, what's my gradient going to be? There's a couple of different ways we could figure out what the gradient is based on what we've learned in previous lessons. One way that we could figure out what the gradient is to simply go rise over run. So what does this mean? We would come to our graph and we would choose any 2 points. It doesn't matter the 2 points that we choose. Let's choose this point and this point. And we're going to figure out what the rise is and what the run is. So my rise in this case is, remember the scaling is going up by 4, 4, 8, 12. And my run in this case is 1, 2, 3. So that means my rise over run would be a rise of 12 and a run of 3, which is equal to 4. Now, it's very important that you realize that it doesn't matter which points we choose. For instance, if I chose this point and this point, well, what is my rise this time? Well, I'm going from 8 to 12, so that's 4. And what is my run? Well, I'm going from 2 to 3, that's 1. So in this case, I would be going a rise of 4 and a run of 1. 4 on 1 is 4. Do you see how it doesn't matter which points we choose? We're always going to get the same gradient. Now, there's actually another way we could figure out the gradient without actually having to figure out the rise and run here, and it's by looking at our table of values here. Here are my table of values. We've learned in previous lessons that the way in which you can find the c value is simply doing this. I know that each time I'm going up by 1 each time, right? And when that's happening, I just need to see what the difference in my y values are going to be. Well, what's the difference in my y values here, or d values, if you want to be, correct? Plus 4, plus 4, plus 4, plus 4, 4, 4. It doesn't matter which way you do it, as long as you understand what the gradient is. And you'll probably already noticed something as well. I'm told that the constant rate is 4. So that 4 there is my gradient, isn't it? The constant rate, it's going up by 4 each time. So by finding the gradient or by looking at the table of values, we're really just doing what we already know, aren't we? We know that the constant rate is 4 because that's what they've told us. So I could come down here and I could just write, m is equal to the constant rate. And I know that the constant rate is 4. The moral of the story is, as long as you know the different ways of doing this, it really doesn't matter how you do it. The easiest way, of course, would just be going, well, the constant rate is 4. That's how you do it. Okay, now, once we've done that, we actually have to put it all together now. So remember, we started off with d is equal to mt plus c. I know that my c is equal to 0, so I can go plus 0. And of course, I don't have to write plus 0, do I? I could just write it like that. And then my m is 4. So I put a 4 here instead of an m. And that right there, everyone, is going to be our answer. So let's put a box around that. And now let's move on to our next part of the question here. All right, we say, use your rule to find the distance traveled for 2.5 hours of walking. All right, it says use your rule. So what do you think a good first step here would be? Let's actually write down what the rule is. It's d is equal to 4t. Then it says find the distance traveled for 2.5 hours of walking. So they've given me 2.5 hours of walking, and they're asking me to figure out what the distance is going to be. They've given me the time. Sub in t is equal to 2.5. Because you see how it says 2.5 hours of walking? Figure out the time. So we want to sub in the time. So we're going to come over here now, and we're going to go that d is equal to 4, and then into my t spot, I'm going to put 2.5. Now, don't freak out. When you are given kind of ugly numbers like this, you will be given a calculator, but you should also be able to do this one in your head. It's not too tricky. It's going to be 4 times 2.5 is going to be 10. So d is equal to 10. Now, it's important that we can kind of translate what we've just done mathematically into words. What is this saying? This is saying that after 2.5 hours, you've walked 10 kilometers. it's important to be able to take the maths and write down what actually is happening there. So that's what's happening. All right, let's now move on to our next part here. It says use your rule to find the time taken to travel 8 kilometers. Again, it says use your rule. So let's take the rule that we found. D is equal to 4t. And now we're using this rule. It wants us to find the time taken to travel 8 kilometers. Do you see that they've given me the distance? Over here, they gave me the time. This was the time. When we were given the time, I let t be equal to 2.5. But in this case, I've been given the distance. So I'm not going to let t equal anything. I'm going to sub in d is equal to 8 because I've been given the distance. So that means I'm going to come over here now, and in my d spot, I'm going to put an 8, and then I'm going to have 4t. It wants me to solve for the time. So what I need to do is I need to solve for t. So I'm going to take my rule here, and I'm going to rearrange it to get the t. 8 is equal to 4t. I want to get that t by itself. So what am I going to have to do to both sides? I'm going to have to divide by 4. I'm going to have to divide by 4. So that means what I'm going to end up with here is 2 is equal to t. And now we should be able to write this in actual words. So what is this actually telling me? It's saying that it takes 2 hours to walk 8 kilometers. And let me just write that up there. That is what it's telling me. It takes 2 hours to walk 8 kilometers. Perfect. Having now done all of this and gotten all our answers there, and hopefully all that made perfect sense, we're now going to move on to our next example. So let's scroll down here, and I've put the key ideas here. So if you want to, you can read up on these key ideas and just have a read through yourself what's happening. But I'm actually just going to jump straight into the next example here. Before I do that, let me briefly talk about it. As we spoke about before, the gradient is the rate of change, and this thing right here, the constant, that's the value of v when t is equal to 0. So we've got different variables here, and we'll talk about this example soon. But the thing that I really want to impress upon you is that my gradient is the rate of change, and then the constant value is going to be what it is when your independent variable is equal to 0. You can come back and you can read this in your own time, these key ideas. It's more helpful for us if we just work through an example here. So let's talk about this example, and hopefully the key ideas, when you go back and read it later, will make a bit more sense. All right, so let's go through this example here. It says, the initial volume of water in a dish in the sun is 300 milliliters. The water evaporates and the volume decreases by 50 milliliters per hour for 6 hours. Draw a table of values using t for time in hours and v for volume in milliliters. Okay, so let's think about what they're asking us to do. We've got two variables. We've got t for time and v for volume, and we have to create a table of values. We know that my t is my independent variable, and in this case, my volume is going to be the dependent variable. Now, we have to read the question carefully. It says the water evaporates the water evaporates and the volume decreases by 50 milliliters per hour for 6 hours. Let's begin by drawing for ourselves a picture of what's actually going on here. So we'll come here and we've got this dish. This is the dish. Let me label it. It doesn't look like a dish. It looks more like a cup, but whatever. It's a dish. We're told that the initial volume in this dish is 300 milliliters. 300. It's been left in the sun and the water's evaporating away, which means every hour I'm losing 50 mils. So after an hour, I'm at 250, then I'm at 200. It's slowly going down and down and down until I'll get to a point in which I have no water in it at all. But initially, we know it has 300 milliliters because that's what it says. The initial volume is 300 milliliters. Okay, now it says, draw a table of values using t for time and v for the volume of water. We're doing this for the first 6 hours because that's what the question says. So I'm going to go 0, 1, 2, 3, 4, 5, 6. What is the initial volume of water when T is equal to 0? The initial volume is 300 milliliters. This is the important part. This is really important. What this is saying is that when T is 0, my volume is 300. That's what it's saying to me. And you can think of our diagram here. When T is 0, I've got just the initial amount, which is 300. Then with each passing hour, I'm losing 50 milliliters. So after an hour, I'm then at 250. So 1 hour, 250. Then after 2 hours, I'm at 200. 200. Then after 3 hours, I'm 150. I'm 150. And after 4 hours, I'm 100. And we just keep on going here. We're losing until, here we're 50. At 6 hours, I've got nothing left. It's all gone. It's all evaporated away. All right, having now completed our table of values, let's see if we can draw our graph on it. Again, what we have to realize is that my independent variable, so my x-axis is T, and my vertical axis here is going to be the volume. That's the first thing that we have to recognize. Then we're going to plot our points. Actually, before we do that, we have to put some scales in here. We're going up by ones here. That's pretty easy. And again, the scaling is really dependent upon how you've drawn it, so don't stress out too much. Then as I'm coming up here, I'm going to have to go up by, now I have to get to 300. I'm going to go up by hundreds. Then I put my points in. So I've got 0 and 300. So when T is 0, this is 300. When I've got 1, I've got 250. When I've got 2, I've got 200. When I've got 3, I've got this. When I've got 4, I've got 100. When I've got 5, I've got 50. And I've got 6, I've got that. So that is what my graph looks like. Having now drawn the graph, I now need to write the rule using V and T. Again, what you're going to do here is just begin by saying, well, I know that my rule is y equals mx plus c, but instead of y and x, I'm dealing with v and t. I know that c is my y-intercept, or in this case, my v-intercept. So I could write v-int. And in this case, it's 300. My m is my gradient. And I know that my gradient is simply the constant rate of change. I'm going to have to go down to the next line here. So that means what I could do is I could just come up here and say, well, it's decreasing by 50 milliliters. Now, because it's decreasing, that means it's not just going to be 50. What it's going to be is negative 50. Remember, you can also think about this in terms of your rise and run. So if you wanted to, you could come over here and you could say, all right, what is my run? Oh, sorry, what is my gradient here? Let's start at this point and let's go to this point. So there's my run, there's my rise. Well, as you can see, I'm going 1, 2, 3, 4 across. That's my run. And my rise is going down, isn't it? I'm going down 200 because this is a scale of 100 each. So it's minus 200. So that means I'm going to get minus 200 over 4, which is equal to negative 50. That is the same as that. You could also, if you want to, just figure out how much you're going down by for your V values here. And it's quite clear that I'm going down by 50 each time. Remember, this is another way of figuring out your gradient by looking at your table of values and figuring out what the difference in the Y is as X increases by 1. So that means as we come now to fill in what our rule is, it's simply going to be my volume is equal to my M value is negative 50 T, and then my C value is plus 300. That, everyone, is going to be my rule that I use. V is equal to negative 50 plus 300. You can come up here and now read the table, this key ideas here, and you can understand it a bit more. The rate of change is your M value. The value of V when T is equal to 0 is the C value. So this is M, this is C. And you can kind of see how this thing is working here. But again, it makes more sense with the diagram and the example here. All right, let's finish this off. Last two questions here. It says, use your rule to find the volume of water in the dish after 4.2 hours in the sun. It says use the rule, so I'm going to take this rule here. My volume is equal to negative 50 T plus 300. Perfect. So we need to make sure we write our rule out first. Then it says find the volume after 4.2 hours in the sun. So we're going to sub in the time that they've given us. Sub in T is equal to 4.2. So that means what we're going to do now is we're going to rewrite it, but instead of T, we're going to write 4.2. So my volume is equal to negative 50, 4.2 plus 300. You can just get your calculator out here and you can type it into your calculator. Negative 50 times 4.2 is going to be negative 210 plus 300. So that means my volume here is going to be 90. Again, it's really important that we can write this in actual words. So what is this actually telling me? It's telling me that after 4.2 hours, there is 90 ml of water left. It's telling me the volume of water after the time has passed. So how much is left after that? Okay, next, very similar again to what we saw in our previous example. Use the rule, so write down the rule, negative 50T plus 300, and use the rule to find the time taken for the volume to reach 75 milliliters. Okay, so how are we going to do this? We're going to sub in my volume is equal to 75 because they've told me the volume is equal to 75 and I'm trying to find the time. So that means I come here now and into my V spot, I put 75, negative 50 T plus 300. I then do some rearranging here. So I'm going to get rid of 300 from both sides by subtracting. What is 75 minus 300? It is minus 225 equals negative 50 on T. Then I need to get rid of that negative 50 T there. So I'm going to divide both sides by negative 50. Again, you can use your calculator here. Negative 225 divided by, now I've forgotten something here, haven't I? We're dividing by negative 50. That's important. We're dividing by negative 50. And the reason why that's so important is because a negative divided by a negative is going to be a positive. And when you use your calculator, you figure out this is going to be 4.5. It's very important that it's a positive there, isn't it? Because a negative divided by a negative is a positive. And then last but not least, it's important that we can take this and actually write down what it's saying. So this is saying that after 4.5 hours, there is 75, it was 75, wasn't it? Yes. That's a funny looking 5. 75 milliliters of water left. That's what it's saying. After 4.5 hours, there is 75 milliliters of water left. And that is it, everyone. That is how you do this topic. That is how you think through these questions. Hopefully now you can come back to this key ideas and make a bit more sense of it. If the rate of change of one variable with respect to another is constant, then the relationship between the two variables is linear. So the rate of change here is your m value, and the c value is the value of v when t is equal to 0. And here's another little example of it. But again, hopefully you've made sense of both the examples I've given here, and this makes somewhat sense. Hopefully you enjoyed this video, and I'll see you in the next one.